number 13, I'm going to mention one thing right away. Number 13 is a trapezoidal rule problem plus integrals. All right, and I probably wrote trapezoidal wrong. Trapezoidal. Okay. So this is a trapezoidal rule plus integrals problem. And so just a quick heads up, I'm going to have a lot of context at the beginning. Like the first 5 or 7 minutes is probably just going to be a bunch of blah, blah. And only then will I jump to parts A, B, and C. So make sure you use the timestamps at the bottom if you already feel good about the trapezoidal rule. If you don't, the context is going to help you a lot. So enough talking, or get ready for some talking, better said. We have that. An engineer wants to calculate the cross-sectional area of a dam. The cross-section of the dam can be modeled by a curve and 2 straight lines as shown in the diagram. So the curve is this curve right here. And then the 2 straight lines, which is much more apparent, is this line and this line. All right. And important detail, but this is all in meters, so my answers will be in meters as well. The curve is modeled by function f of x. The following table gives value for f of x for the different values of x in the interval from 0 to 3. So basically what we have in pink, okay, the line in pink is for this table here. Notice it goes up to 3, and so does the line in pink, all right? The curve in pink. So that's basically what's happening. These are just a bunch of different x and y values. For example, this is telling you the point 0, 3. This is telling you the point 0.5, 5.13. This is telling you the point 2, 19, which makes sense because at 2, it does look like I have a 2, 19. Okay, so that's all that's really happening. It's a table with different x and y values. So for part A, we need to calculate an estimate. Okay, calculate an estimate for the area in the interval from 0 to 3 using the trapezoidal rule with 3 equal intervals. So there's a lot going on here, and this is where the context I talk about will begin. Okay, so the trapezoidal rule problem usually follows the same sort of like procedure or stuff you have to do, and let's first talk about it. See, so for some reason an engineer decided to hire a high school student for calculating the cross-sectional area. Okay, so the cross-sectional area, just take it as the area under these 3 lines. All right, that's why it's cross-sectional. It's kind of like, it's a couple different shapes. Okay, whatever. So cross-sectional area of the dam. Now, for calculating this area, the lines that are straight in green, it's a little bit more friendly because you can just make like, well, that would be like a rectangle, and this other one would pretty much be like a triangle, right? And so calculating the area of the guys in green, it's not that hard to do, right? I mean, it's pretty basic geometry. Here you would have a rectangle. And over here in dark green, we would have the area of a triangle. So you definitely have the formulas for that. Not that hard, but what we have in pink, you guys, what we have in pink, there isn't a name for this shape. There literally isn't. And so here the big issue is that there is a curve. And so how do you calculate the area under a curve? That's what it is. So for area under a curve, the main tools you have for estimating, so an approx, okay, is going to be the trapezoidal rule, and the exact, all right, is going to be with an integral. So that's the first thing I'm going to establish. The trapezoidal rule is only for a approximate, while the integral is for an exact value. See? So that is why for part A, it is literally asking for an estimate, because the trapezoidal rule is indeed an estimate. Yeah? Now the trapezoidal rule, well, what is that? Where do you find it? Etc. This is in your formula booklet. So I go straight to the formula booklet and I try to find it. So eventually, after searching for a while and trying to spell it correctly, you find it right here. See? Now, This equation, I will go piece by piece how it works, how to do it, etc. But the general overview that I need you to have for now is, first of all, here you have an integral. This symbol that I'm putting in red is the symbol for an approximate. And so the trapezoidal rule itself, which I'm now putting in light blue, is all of this guy here. So all of this guy is the trapezoidal rule, right? So notice, the trapezoidal rule, what it does is that it helps you make an approximate to what the integral would be. That is what I mean earlier by, the trapezoidal rule is an approximate, it's an estimate, while the integral is the exact value. Now you might be telling me, okay, why is this relevant? It's relevant because further down the line, and in a lot of these types of exercises, part A is for the estimate, and part C is for finding the actual area. So if you want to find the actual area, you're not using trapezoidal rule, you're using integrals. So that kind of language is important to keep in mind. Okay, that's why I'm going over that in the first place. Secondly, let's talk about the trapezoidal rule, what this formula has, what it doesn't, etc. See? Now, if you were to want to understand this, or if you want to write down like the cheat sheet or like the way to solve it immediately, and I will go piece by piece, but for now, this A is your smallest x value. This B is your biggest x value. And so B for biggest and A is the other one, so A is going to be for smallest. Okay? You can also think about it like B is up top, so it's bigger, A is on the bottom, so it's smaller. Okay, whatever. See? A is going to be your smallest x value, and B is going to be your biggest x value. Now you might be thinking, isn't that on the integral side? And I say, yes, it's on the integral side, but it's also what you need for finding h. And h is in the trapezoidal side, trapezoidal rule side of the formula. See? So anyways, for all this stuff that you eventually end up plugging in, let's understand piece by piece. A is the smallest x value. B is your biggest x value. Now, everything else is going to be y values. See? So for example, this y0 is your first y value. This yn is going to be your last y value, okay? And this that I'm putting now in orange, all these different y values, okay? I know it looks kind of crazy, like y1, y2, yn minus 1, like what is that? See? What I need you to understand is that within this parentheses, all that you're going to put, adding each other, so all that you're going to put is all the other y values. Okay, this is a lot more friendly to understand than if I were to talk about y1, y2, y3, and all that stuff. See, I'm going to talk about it anyways because, you know, I should, so that you understand it. But understand this. See, for the trapezoidal rule, on the one hand, you first need to calculate h. See, h, you're going to need the smallest x value, which is going to be a, ¿cierto? And the biggest x value, which is going to be b. You also need n, okay? And n is actually going to be technically n, let's take it as amount of, how should we do it actually? Yeah, amount of points used minus 1. Okay, and I'll talk about that more later. For now, if you want to write down like immediately how to use it and solve it and etc., this is what you would write down. See? Now seeing it in action, you're going to understand how I get n, how I get y0, how I get yn, how you get b, how you get a, and all that stuff. See, but for now, I highly suggest you write down somewhere that this is the how the trapezoidal rule works. See? it's no use having the formula in front of you if you've never actually used it or don't know how it works. See? So on the one hand, you're calculating h, which uses the biggest and smallest x values alongside the amount of points used, -1. And then you have two main parentheses. The first main parentheses, which I'm going to put now in whatever, in red, so this parentheses is simply the first and the last y value added together. And then the second parentheses is all the other y values added together. All the other y values added together. So let's go back to the exercise and try to identify some of this stuff. Again, the trapezoidal rule is not used for the entire figure. It's only used for the areas under a curve. And so we're going to be using it for this part in pink. For this part in pink, I have this table here, right? For these different x and y values. Now, careful. You're not going to be using all of these x and y values because the exercise is specifically asking for you to use 3 equal intervals. Now, usually, in my experience, you do use the whole table and forget about it and bada bim, bada boom. But if they want 3 equal intervals, and this goes from 0 to 3, well, from 0 to 3, clearly you have 3 meters, right? And so if you were to divide these 3 meters into 3 equal intervals, you would have to go 1 meter at a time. All right, so the equal intervals, which I'm going to be putting now on your screen, go like this. This is your first interval. This is your second interval. And then this is your third interval. Okay? If you were to try to do it at a different amount of intervals, for example, increasing by 0.5 each time, this is one interval, this is another, and then this is your third. And so that would be 3 intervals, and you don't reach 3. You would have to add a bunch of more, and then you don't have 3 equal intervals, you have 6 equal intervals. See? So for the equal intervals, clearly you gotta go 1 whole meter at a time until reaching 3. And so if you go 1 whole meter at a time reaching 3, that means you're stopping at 1, stopping at 2, stopping at 3. So you don't care anymore about this point at 0.5, or the one at 1.5, or the one at 2.5. So now these are the values you're working with, okay? Once you establish that, we go back to the formula booklet and we first need to realize, okay, what is the smallest x value? See, for A, what is the smallest x value? It's this guy here. So this will be A. So A equals 0. Which one is the, and let me put it in blue. See, so we just got the smallest x value. What is this biggest x value? So biggest x value is right here. So this is the biggest x value we said was B. B equals 3. So now we can check over there, right? What else do you need to identify? Well, you need to identify the first y value. So the first y value is going to be my first point. It's right here. So this is y0. Y0 equals 3. Check, right? And then we also need to identify the last y value. And so the last the last y value, notice they call it yn. So my last y value is this guy here, and I'm going to say that this is yn, and that yn is going to equal 42. Now I'm going to make a quick disclaimer here because I think it's worth doing it right now. See? This is your last y value. Right? And so if this is your last y value, then this is yn. Now notice, how many n's do you actually have? How many n's do you actually have? All right, so if this 42 is yn, then it's your last y. So that's your last sort of set of points that you're going to be using. But here's also an interesting observation, right? And this is also going to help you understand why you have y1, y2, y whatever over here. See? Technically, if this guy's y0 on 3, then the one right next to it is going to be y1. And then the one right next to it is going to be y2. And so then the one right next to it is not only yn, it's also y3. So, that's what's happening here. So the yn is signifying that's your last y value. But depending on the context, maybe you have 10 y's. Maybe you have 20 y's. Or maybe you only have 4 y's, and because you start counting from y0, then that means that your yn is y3. So that's also an interesting sort of observation. So your first y is at 0. And I know that seems very troll, but I'm just being honest. That's what the formula says. So get used to it. Your first y is at y0, okay? And so if your first y is at y0, and here technically I have 4 y's because we do have 4 sets of points, 1 set of points, 2 set of points, 3 set of points, and 4 set of points. If your first y is at y0, then your last y, in this case, is y3. So notice, 4 points means last y is at y3. So be very careful with that. See, I highly suggest you do the same that I did here. Go to your table, start counting from y0, figure out which y you reach, and whichever y you reach is going to be your yn. So yes, you have 4 points, but your yn is y3. And if yn is y3, then the obvious conclusion is that n has to equal 3. Okay? So yes, you can memorize, it's the amount of points you used minus 1. Or you can go one by one, and by like intuition or just concluding, looking at the last one, like, oh, this is y0, this is y1, this is y2, this is y3, but it's also my last y. So if y3 has to be my last y, then clearly n equals 3. All right, that's what's happening here. Okay? So enough blah blah. Looks like we identified pretty much everything we need. See? So we talked about the first value of y. We talked about the last value of y. And if this is my first and this is my last, y0 and yn. So if this is my first and then this is my last, okay, notice I'm putting it in red. So for the first parentheses in red, that's my first, that's my last. For all the other y's, which is for the second parentheses in orange, it's going to be this y and this y. Okay? So now I can check over here as well. Vale? I already got the value for b, the value for a, and the value for n. So now we're good to go and plug in. See? So if I were to go ahead and plug in, well, first let me rewrite the equation over here because I do want to have it in hand. And so the equation is, for trapezoidal rule, 1/2 times h, big parentheses, y0 plus yn, plus 2 on the outside, times y1 plus y2 plus who knows what else, and then close parentheses. Remembering that h equals b minus a divided by n. Okay? So now I'm like more reaching like the heart of part A. See? So for part A, once we understand trapezoidal rule and you identify each one by one, okay, we can now safely say, and understanding the formula at a deeper level, you can have 1/2 times h, parentheses, first y plus last y, close parentheses, plus 2 times all other y's added together. And then close parentheses. See? Here's a bigger parentheses as well. Let's remember that for the first and last y, it's the ones I'm putting in red. And for all the other y's, it's the ones I'm putting in orange. Okay? So again, understanding the formula is probably the hardest part for this exercise, right? For h, it's going to be, well, b we said was 3, a we said was 0, n we said was 3. So h is actually just going to be 3/3, which is just going to be 1. Okay, so now I can plug into my calculator everything I have here. See? So I have to put 1/2. I'm going to use it as a fraction. So alpha y equals, and the first one, so 1/2 times h, which we just said was 1, times, and then here is the big parentheses. See? So first the parentheses in red, which we said was first y plus last y, which clearly has to be this 3 plus this 42, close parentheses, plus 2 times the parentheses in orange, which is all the other y's added together. So it's going to be 8 plus 19. Make sure you close the parentheses as you should. And then that is for part A. See, so for part A, you plug into this equation here. Make sure you write it out to show the procedure of the trapezoidal rule. But you do end up with 99 divided by 2 meters, which if you don't like fractions, because let's be honest, almost nobody does, you can leave it as 49.5 meters. Okay, so that is for part A. Then they tell us that it is known that the derivative version, because notice it has a little bit of a thing there, the derivative version equals this in the domain from 0 to 3. So in the domain from 0 to 3, we're still simply under the curve, the curve that is pink. Yeah. And so for part B, you need to find an expression for f of x in the domain from 0 to 3, still under the curve. Now here's another big sort of concept I need to go over. It's the following. On the one hand, the 3 types of functions you're gonna like run into, okay? It's that you have the original one, the classic, right? It's just gonna be f of x. Then you have the derivative, which we just talked about, which is, it's like the classic, but it has a little bit of an apostrophe here. See? The same that is appearing right there. So that is for derivative, right? That literal apostrophe thing. And then the last thing you can encounter is the inverse. For the inverse, it's very similar to the original, just that it has a -1 up there. Okay? So these are the 3 things you can encounter. Now, a big brain play, okay, is the following. To go from the original to the derivative version, what do you have to do? Pretty obvious. You gotta do the derivative. However, ladies and gentlemen, and this is the thing you have to know for this exercise, to go from the derivative to the original, you gotta do the integral. And so, will you look at that? You can go from the original to the derivative, doing the derivative, and go from the derivative to the original, doing the integral. So for part B, they gave us the derivative version, which is 3x squared plus 4. And so if you apply the integral to this guy, you're going to end up with an OG. Yeah? So, an integral. I know that's probably spooky, and trust me, it sounds spooky, but it's not that terrible. See? So because we're talking about an integral, you're going to go to the formula booklet and ask for help. And eventually, you're going to find this guy here. See? The only integral you have to know is the integral of an exponent. Okay? Here they put it as x to the power of something. It's the same as the integral of an exponent. Okay? Now, if you follow this formula, you're going to be just fine. See? The other observation I can do is that this is basically like what you do with a derivative, but backwards. So if you want to think about it that way, you can. An integral is a derivative backwards. That's also why I drew this diagram here. So if you're really good at the derivative of an exponent, well, now just apply the same thing, but thinking backwards. What's the integral of it? Go from there. Yeah? So, clearly, all you really have to do is take whatever your variable is, ¿vale? And then the exponent, you're going to add 1 to it. And your exponent, right, is also going to go on the bottom. And you will be also adding a constant, which I'll talk about in a second. See? So let me actually go first over the constant, because that's probably the weirdest part. See, this is the constant. It's a classic. You pretty much have to include it for integrals. ¿Vale? Imagine a random example that I'm making up on this spot. Imagine you have the original function x squared plus 2x plus 1. If you were to do the derivative of this guy, you end up with 2x plus 2. Why does this happen? Because the derivative, all it really does, notice the derivative, this n, right, goes in front, multiplying, and then you do minus 1 to it. And so here what happened was that this 2 went in front multiplying, so it was 2 times 1. Then we did minus 1, so you ended up with 1 up here. That's why you still have an x surviving, see? Then for this guy here, you have x to the power of 1, so it was 1 times 2. You end up with only the 2. Here, there's technically an x to the power of 0. Anything to the power of 0 is equal to 1, so you just leave it like that. And for this last one, technically there's an x to the power of 0, so 0 times 1 makes it go away. So notice, here we went from the OG to the derivative. And if I were to do the integral here, in order to reach the OG, well, what happens? If you were to do the integral of the derivative in this context, in an attempt to reach the OG, you're going to get really close. So on the one hand, following the formula, all you have to do is take the exponent you already have and add 1 to it, and your exponent will also go on the denominator. So from here, the 2 that I'm putting now in red, in red. So this 2 will remain unaffected. What will be affected, and this is the part of like the integral of the formula, see, is that this x will have 1 plus 1 up top, because it is to the power of 1. And then down here, you will have the exponent. So you're going to have 1 plus 1. See? Close parentheses, plus 2. And then here's the same idea. Here you have x to the power of 0. So technically from here, again, you put the 2 on the outside, so untouched. But you will put a big parentheses. Here's the part of the integral. You're going to do x to the power of 0 plus 1 divided by 0 plus 1. And from here, you also need to put plus c. Let me keep going. So if you keep going from here, you end up with 2 times x squared divided by 2 plus 2 times x to the power of 1 divided by 1, right? Now divided by 1 does nothing, so you're just going to erase that right here. 2 divided by 2, it's also going to go away. And then you have the plus c, which is mandatory because of the formula right there. So you have to include the constant. But notice, so you have f of x equals this whole guy, see? And so we used to have plus 1, and because this is the thing, because in the derivative, this 1 disappeared, then when you do the integral, you have to put plus c. You have to say, there's a constant there that could have been there, right? I don't know if it's plus 1, if it's plus 2, if it's plus 420, plus 100, like who knows? But you have to acknowledge when you did the integral from the derivative, there could be a constant that you're missing. So that is why you put plus c, it acknowledges the plus 1. Now technically from here, if I observe just from here, right, if this is the screenshot that I'm taking, you have no idea what that constant is. Because of context, you know that it's plus 1 because I made it up earlier, see? But technically, you have to find out what that constant is. Dale? So that was a quick 101 on how integrals work, especially from the derivative, which is exactly what we gotta do down here. So doing the integral from the derivative from here is the same idea. So you're gonna end up with the original function. This 3, again, you will not touch it. You will not touch the 3, but you will do the integral of the x squared. So the 3 remains outside, and here you follow the formula. So in the formula, you will be taking your exponent and doing plus 1. So you take the exponent, which is 2, so x squared plus 1, and then you divide by the exponent. Notice what I'm putting circled in green, or actually let's be very, very clear, what I'm putting circled in whatever, pink, see? So this is my exponent, which goes on the division denominator thing as well, see? So 2 plus 1, 2 plus 1. Close parentheses, plus this 4 will also remain untouched, right? Technically, right now, there is an x to the power of 0, ¿cierto? So that means I am doing big parentheses, x to the power of 0 plus 1 divided by 0 plus 1. All right? And follow the formula. There's a plus c. So here I put the plus c. You work this out a little bit more. You end up with f of x equals 3 x cubed divided by 3 plus, oh, this is multiplying, plus 4 times simply x, right? Because this would be x to the power of 1 divided by 1. No need to put it. I can just leave it like this, plus c. And the last detail is that this 3 goes away with this 3, okay? So this is my original function. But notice for part B, you need to find an expression for f of x. And this is almost done because you still have a c that's going around. So how do you solve for that c that's going around? Well, notice, right now you technically have 3 variables. So your 3 variables are x, both of these x's, the y, which is the entire f of x, and the c. And so the big trick, which you will pretty much always do, so just write it down somewhere, is that you're going to plug in a set of points. And if you plug in a set of points, you're going to figure out a value for x, you're going to figure out a value for y, and now you can solve for c. So just go with the flow for now. See, the big step I need you to acknowledge is that after the integral, you got to plug in a set of points in order to figure out what c is. And so the set of points that I will be plugging in can be any of these 4. And I'm going to choose it to be the first one because, well, it looks like the friendliest one. See, 0, 3, why not? Yeah. So from here, I can just plug in the first one. I'm going to be plugging in 0, 3. So that means I end up with 3 equals 0 cubed plus 4 times 0 plus c. This goes away with this. This goes away with this. C has to equal 3. And so if c equals 3, your OG function now ends up a lot more pretty. And this is the final answer, see? So f of x has to equal x cubed plus 4x plus 3. Let me put it in blue so that we all agree that this is the final answer. There it is. A little bit of a lengthy process, but the cool thing about it is that it's always the same process, see? So very trainable, very attainable. Huh, that should be like a quote. If it's trainable, it's attainable. Dude, you guys got this. All right, that was for the doing an integral from the derivative to find the expression of the OG. See? So keep it in mind. If you have the derivative, do the integral, you end up with the OG. Yeah, the line that I'm doing in blue. All right, and last but not least, you need to do part C, which says find the actual area of the entire cross-section. And so the entire cross-section, what you will be adding is 3 shapes. So the first shape is this guy in pink, which I will be calling number 1. Then we have light green, which is this rectangle, right? And then we have the one in dark green, which is this third one, which is a triangle, okay? So from here, find the exact area of each. Now, I did say way back in my day that the exact area will be used or will be done with an integral. And so right now, all you have to do is do the integral of the function of the first curve. And the function of the first curve found from part B is this guy here. Okay. So technically, I'll do it up here because I guess there's a little more space. So technically, what you have to do for this part, ¿cierto? Is that you need to add, let me make a little bit of space. From this part here, what you need to do is that you need to add the area under the curve, that's the thing in pink, plus the area of the rectangle, which is light green, plus the area of the triangle, which is in dark green. Okay, so if you add up these 3 exact areas, you're going to be good to go. Yeah, so let me make a little bit of a visual component. For the first one, it's a little bit of like the curve thing, right? For the second one, it's the rectangle. And for the third thing, it's the triangle at the end. Okay, so for the area, I'm going to put big A for area. See, so for the area of the curved part, we said that we need to use the integral. So here you do the integral, okay, of your function. So the area, your function we said was this guy here. So we're going to be doing the integral of this. And I'll show you how it works, don't worry. But for now, follow the idea. For the exact area, you got to do integral. So from here, you can do integral of your answer from part B, which is x cubed plus 4x plus 3. Let me double check just in case. Sounds good to me. See? Now, the other thing you have to do is that much how over here, right, for the trapezoidal rule, you talked about A and B. Okay, you also have to define that. See? So A is your smallest x, B is your biggest x. So A is 0, B is 3. That will apply over here as well. So this is going to be 0. This is going to be 3. This is your, what we call y, so your function. And here you put dx. So let me talk a little bit about what's happening here, because I know it's kind of crazy. So on the one hand, what you're doing is, this is what you're going to be telling, like in math terms, this is what you're saying. Of this function, I need to do the integral in respects to x. That's why you're saying dx. And I need you to find the area of this function from 0 up until 3. That's what's happening. Let me go over it one more time because it's very important that you have it clear. So right here in math terms, you're saying of this function, I need to do the integral in respects to x. And I need you to do the integral from 0 up until 3. That's all that's happening here. So once we bring the math over to more intuitive terms, it makes a lot more sense. See? So this is going to be for the area in pink. Then we have to add the rectangle, which this is a little bit more friendly. See? So for the rectangle, you can observe, right, that it goes from 3 to 4, right? So over here, the dimension of the triangle is a distance of 1, right here. That is going to be a distance of 1. And then the height, well, notice this point here, right, is at 3,42. So over here, you have a height of 42. So that means my base of my triangle is 1, and the height of my triangle is 42. And for the area of a triangle, I actually don't know if of a rectangle. I don't know if we have the formula here. I mean, you should probably know it, but area of a parallelogram works. See, so base times height. Base is going to be 1, height is going to be 42. So for the area of the rectangle in green, we're going to be doing 1 times 42. This is for the area of the rectangle. And now for the last part, you need to do the area of the triangle. And so the triangle, well, area of triangle is right here. Base times height divided by 2. The base goes from 4 to 6, so that's going to be a base of 2. And then the height is once again going to be 42. And yeah, so base times height divided by 2. So it's going to be base times height divided by 2. So this is going to be the area of the triangle. See? So that's going to be the area of the triangle. Notice that I can do this because I can observe that this touches here on the 0, right? And I know that these are straight lines because the problem told me earlier, here you have 2 straight lines. See? So those are very important observations that we have to do. It allows me to talk about the problem like this. See? So all of this, you got to pop it into your calculator and you will solve it. See? Now the weirdest thing for you probably is popping this into your calculator. So let me help you piece by piece. Open up your graphing calculator and go to math, because this is a very mathy thing to do. Go to math, and here you have a bunch of mathy stuff. See, when you're doing crazy mathy stuff, you gotta press math, yeah? On your first tab, on the math tab, eventually you're gonna find fn int. And what this is saying is the function of the integral, or something like that. See, like function integral, I don't know, whatever. You press here and look at that. It's everything you need. So you're gonna be putting 0 up until 3, so that it's following the procedure from earlier. This is your function, or your y, ¿cierto? That's going to be your entire expression. So x cubed plus 4x plus 3. And all of this will be done in respects to x. See? Just so you trust me, I can technically press enter, and that's going to be the exact value of my integral. See? Now, just to be a little more fancy, you can do it all in one line. So that's going to be your integral. Then you can add on to it the rectangle that's in green, so 1 times 42, plus the rectangle, plus the triangle, sorry, which is going to be 2 times 42 divided by 2. So I can do it all together in one line. I end up with 131.25. If you want to go piece by piece, you can go piece by piece. I went ahead and got fancy and did it all in one go. Either works. So the area, the exact value of the area has to be 131.25 meters. And since they're asking for exact area, I'm going to leave it with the decimals and everything. See? So that would be for part C. Let's check our answers just in case. But it looks pretty good to me. So on the one hand, here's the 49.5 from the trapezoidal rule. Notice that you have to first put the equation of the trapezoidal rule. You have to be showing as a method point that you're trying the trapezoidal rule. See? Then recognition of needing to integrate. That is why the context is so important of understanding that, if you have the derivative version, do the integral for the original. See? That is a very important piece of information for these exercises. And they always, from what I've seen, they always want you to figure out what C is. See? So again, for finding C, maybe write this somewhere. See? For finding C, plug in a set of points. So plug in an x comma y. If you plug in an x comma y, you're going to find the value of C 100% of the time. ¿Vale? And then for part C, well, there's a couple different methods, but the main one, the friendliest one in my opinion, is understanding what I said earlier, which is, this is the first part, the curvy part. This is going to be the rectangle, and this is going to be the triangle. See? For me, that is the most friendly way to approach it. And you end up with 131.25. Do not forget your units. I put meters, but this is for area. So this is actually meters squared. So we all make mistakes. I just did one. No one's human. Don't be so hard on yourself. That is how you solve number 13. It's pretty crazy. But in my opinion, once you understand how the trapezoidal rule works and the integrals, everything becomes much more friendly. Do not fall into the trap that, I have my formula booklet, so why do I need to, learn the formulas like to the dot? And you have to learn them to the dot, because what use is having these formulas if you don't understand how they work? I'm sure a lot of you, maybe they read trapezoidal rule in this exercise, they went to the formula booklet, you looked at it and you said, I have no idea what's going on. Starting off with the fact that the first y value is y0. Why is it y0? What is yn? What is going on? That's the kind of stuff you have to know. See? There's no use in having the formula if you have no idea how it works. So, I hope this video helped a little bit with that. That is for number 13, and I hope it helped. I'll see you around.